Hello everyone. Today I'm showcasing the DiMAT Materials Modeler, or DMM, a key component of the DiMAT suite for advanced material manufacturing. DMM is designed for material scientists, process engineers, and R&D teams who need to predict materials properties based on their data and optimize manufacturing parameters without extensive lab testing. The DMM toolkit is offered as a cloud-based solution through our web platform, and it addresses a critical challenge in materials development, predicting material behavior under different manufacturing conditions without the costly physical experiments. Our solution transforms this process by utilizing AI-driven models to predict material properties based on composition and process parameters, identify optimal manufacturing configurations, analyze which factors most significantly impact materials performance. And what makes DMM truly stand out is its ability to combine machine learning with material science expertise, delivering scientifically sound and practically applicable results. Now let's head over to the actual solution. This is the homepage where we can actually sign in using Keycloak. After signing in, we can go to the first functionality, which is the exploratory data analysis, where we can upload our data, select which parameters we want pertaining to the actual data we have uploaded in the sidebar, and then we can actually see the data, see the missing percentage, which is a usual thing in real-world data, as you can see here. Afterwards, we can perform imputation and see the correlations between the parameters that are involved in the data we have just uploaded. As you can see here, we can download, of course, everything in terms of data, as you can see in the bottom page here. And also we can visualize the outliers, which is quite handy for a data scientist or a materials expert to do, as you can see in this page of the solution. And of course, again, we can download all the data there. Afterwards, moving on to the feature importance functionality, we don't need to re-upload the data. We can actually use the data we already have. And we can, for now, run our model to see, to actually fit a machine learning model to our data and estimate and evaluate the feature importances. After the model runs, we will be able to visualize it. As you can see here, we can see the feature importance per target parameter. And then as they are grouped here, you can see in different color the material, which is the composition parameters, and the blue color, which are the process parameters for each parameter involved. And then we can see the group parameters, group between process and materials parameters for each target parameter. And of course, we can again download the report for that. Moving on, there is the actual model training. We can actually use either univariate or multivariate. I have selected here the univariate model, so we're training models according to the number of target parameters we have. In this particular data set, we have 3. And after obtaining the models, we can again download the model specifics, or we can move on to the materials property prediction, which is essentially an inverse search, which it utilizes the different models we have already trained, and it's a hybrid use between the actual the machine learning models we have and genetic algorithm that helps us to find and minimize the objective function behind that. So as you can see, we have actually cut off a bit of that in order to save time for the video, and we can have we can set as constraints a lot of materials properties and keep some vacant, as you saw. What we get from this model is ranges of the desired parameters we need to actually calculate, and also we can download the results. You can see here the ranges, and then we can actually see a confidence score of how good our actual results are. Last but not least, the other functionality we have is uploading again our data and chatting with them through the use of an LLM. This is an agnostic service. The user can connect to whatever LLM they want. Now I'm connected here in a local LLM, which is open source right now. And as you can see, we can ask it questions pertaining to our data. It is very good in summarizing what the data are, and also inferring things from the actual data we gave it. It is fluent in code. If the data scientist wants to do any additional exploratory data analysis, for example, or develop their own models. Here I'm asking it about the data themselves, and it is trying to infer, and it is actually very good at it, what each parameter that it sees in the data is. This is just an example. I mean, the user can plug whatever model they want in it, and this will work out of the box. Now, to close, some closing remarks is that the DiMAT Materials Modeler toolkit, as you can see, it has the ability to transform the materials development as we know it. It can assist with optimization by leveraging AI and data science, and it can offer significant reduction in experimental cycles and material waste. Some data-driven insights for process optimization, clear visualization of material process relationships, and accessible predictive capabilities for both experts and non-experts. This toolkit is designed to be user-friendly while delivering powerful analysis capabilities, and we can invite you to explore how it can enhance your materials innovation process. Thank you very much for your time.